Yayati ma'am.
Hi, ma'am. I'm
Hi
here.
ma'am. Good morning ma'am. Hearty welcome to our webinar.
Thank you so much.
Okay ma'am. Good morning sir.
Good morning, madam.
Good morning sir.
Good morning. Good morning.
Happy
I'm
to see
switching
you
on the
sir.
I'm switching on the camera in like 5 minutes.
Sir, pardon sir.
I'm switching on the camera in like 5 minutes.
Yeah, okay sir. Okay sir. We'll be starting shortly sir.
Sure, sure. Take your time. No problem.
Swarna miss?
Yes, Anjali.
We
Anjali,
can start. We can start
yeah.
now. It's
It's
already 10
o'clock. We'll
minutes.
start. First of all, hearty welcome to all the participants and especially Sudarshan sir and Yayadi ma'am for the second day webinar. That is, the topic is data crunching dustbin data to our rescue. The topic itself is creating curiosity among others. I welcome you all. Let us start today's webinar with the silent prayer. Thank you all. Now, Dr. Anjali Kishore, Assistant Professor, Department of Mathematics, Vimala College Autonomous Thrissur, will be delivering the welcome speech.
Thank you, ma'am. Good morning, everyone. The inspirational and brainstorming talks by eminent people like Dr. Sudarshan and Dr. Yayadi are the driving forces towards success during this pandemic period. I, on behalf of the organizing team, welcome wholeheartedly the invited speakers and participants to the day second of webinar series on pure and applied mathematics funded by DBT Star College scheme. Today, we have eminent resource persons who are experts in data science and artificial intelligence, which is actually the need of the hour and the future and present, I would say, of mathematics. Dr. Sudarshan Iyengar, who is the Associate Professor of Department of Computer Science and Engineering, Indian Institute of Technology, Ropar, has completed his PhD from Indian Institute of Science, Bangalore in the year 2012. And till date, he is a faculty at Indian Institute of Technology, Ropar. He has more than 35 research publications and he is the expert in computer science, artificial intelligence. His areas include data sciences and analytics, social networks, social computing, collective intelligence dynamics, crowdsourced technologies, to name a few. He is the recipient of the prestigious ISTE Best Teacher Award in 2017, Special Award as Best Student Motivator by CRSI, which is Cryptology Research Society of India, in the year 2005, and the recipient of many exemplary research grants. I was indeed very privileged to have his consent to be the invited speaker for today's webinar series. Thank you so much, sir, for accepting our invitation and welcome wholeheartedly to this webinar, sir.
My pleasure.
Thank you, sir. Yayadi ma'am, Dr. Yayadi Gupta, who is a PhD student of Dr. Sudarshan. She is the assistant professor at IIIT Dharwad, and her research interests include social network analysis, complex networks, applied graph theory, and her teaching experience include object-oriented programming, theory of computation, and social network analysis. She is also a person with about 9 research publications, and she is the recipient of, she has an acceptance in the terminus of Intelligent Viral Memes Trajectory, if I am correct, I don't know, the primary winter conference in social networks. So on behalf of all the participants and all the organizing committee members, I extend a very hearty welcome to both our resource persons today. Thank you, ma'am, for accepting our invitation and coming here. So over to you, sir and ma'am. Thank you.
Thank you, Professor Anjali. I hope I'm audible and my video is clear.
Yes, sir. Yes, sir.
Okay.
Course, sir.
So I generally have a very good studio at my disposal at my IIT. I have a nice lighting and good mic and things like that. So they're not available right now because I'm in the transition. I'm traveling. I'm in Mysore right now. That we're pretty close to Kerala, but far away from the technological comforts that I have at my IIT. I'm trying to talk to you people over my mobile phone and my earphone and mic. I hope I'm clear. In case I'm not, please tell me, because if the speaker is not clear, the talk will not go well. it's okay if the audience do not have the right infrastructure, but the speakers are supposed to have. Anyways, I hope I'm clear, Anjali ji. Maybe
Sure,
you
sir.
can
Sure,
cross-check.
sir. Sure,
It's
sir.
clear.
Go ahead.
Okay. So, all right. Thank you very much for the wonderful introduction. Although I think I sort of seldom deserve it because I did not do anything consciously. I have been playing around with academics all my life and thoroughly enjoyed doing it. I don't understand academics really well. I don't understand my subjects really well. And that makes it even more thrilling, like a movie where you don't know what is the climax. So in academics, I don't know what's the climax. I'm always on the, I'm a seeker who keeps seeking for the meaning of academics. That way, I've thoroughly enjoyed my stay here in academia. I'm currently working at IIT Roper, a wonderful place where I graduated a few students, one of them being Yayati. Yayati, who will be the speaker immediately after my little introduction. She was my first PhD student, and I would say there's been a lot of things that I've learned from her, and you guys will also learn a good deal of inputs from her in today's talk. Very importantly, I must say, she was one person whom I would envy because if she comes to the class, I cannot go to the class. She was such a good teacher that students would say, send your PhD student, you don't come. That's actually a compliment to me, but at times I have envied her and I'm actually jealous of her teaching skills. Anyways, with that, let me start my little intro to today's topic, the dustbin data. Right. So let me go very slowly, introducing you people of the theme of today's talk. I must confess, I have no stage fear. By that, I mean the fear part is there. The fear of stage not being there is a fear for teachers today. Initially, when we start our career as teachers, we fear the stage. Now, the fact that there is no stage is a fear for us. So I call this the no stage fear syndrome of post-COVID teachers. Right. Okay. So I'll try my level best to make it interesting, and I'm sure we will not. One thumb rule that we use is we never use PowerPoint slides. We think teachers are the points of power, and they should seldom use PowerPoints. But each teacher to himself, it's our style, right? And even if you see Yayati, she'll only be using the terminal and then talking to you people, and I'll do the same thing. All right. Coming to the dustbin data set. What do we mean by this? In the middle 90s. There was this boom of internet all over. Okay, with the internet comes the problem of searching, right? I mean, if you buy a big house, if it's a small house, you know what is where. If the house is very big, if it has some 17 rooms instead of 1 BHK, you have 17 BHK. You don't know where you have kept your cell phone, its charger, its earphone, your books, your pens, etc. Internet became like that from a very small local area network as part of what was called the ARPANET. It was a defense research project back then, a small network. And they used the idea of sending and receiving information through telephone lines. And from there emerged the idea of internet. And after the internet became a big boom, people realized that there's a lot of information here and there. Right? So Manya has raised her hand. I suppose it was by mistake. In any case, the questions can be taken after the talk, if you people don't mind, so that the train of thoughts don't get disturbed. Right? Okay, fine. We will ask you for questions. Maybe then you can ask us questions. All right, getting back, the internet boom resulted in people realizing that, oh, we now have a big house, a bungalow. We don't know what is where in this internet. We probably must fix this searching problem. If someone types, is coffee good for health? It would show up, it should show up the best possible information. It cannot just like that show everything that's available on the internet that talks about coffee. Right? All right. So what people did was Yahoo cracked this problem by hiring thousands of people. Okay. What you can do in your bungalow is maybe hire some 20 people who sort of know what is where. And the moment you say mobile charger, they'll go and get the mobile charger. Or the moment you say my pajamas, they'll go get your pajamas. The moment you say my hair clip, they'll go get your hair clip. Things like that. That's one way of solving it, and Yahoo precisely did this. Yahoo hired a lot of people and said, map the entire internet. If someone types diabetes, they should get all information about diabetes ranked by its relevance. Now, a lot of information is also not a good idea. You go to a hotel, you want to eat something, what you should know is what is really good in, let's say, Thrissur. Okay, what places to visit in Thrissur? Rank the places in Thrissur. I roughly remember when I went there, the Vadaganatha temple was really, really beautiful in Thrissur. That probably is the first thing that we should go for architectural reasons. At least the place is very beautiful. The inside of it is even beautiful. Someone told me this is first ranked. You see the connection. What I'm trying to say is there will be 20 locations which are nice in Thrissur, but can you rank them? The question of ranking became a big problem for Yahoo search. They hired people, they asked them to rank, and they would take the aggregate rank of everyone. So it's like, ask some 10 people what are the good places to visit in Thrissur, and you make the top 3 out of it. Is how the Yahoo worked. I repeat, internet, boom, search, big bungalow, hire people, do the searching easy, right? And then came 2 people who sat in the garage of their place and then asked this question: can we not hire people and sort of automate this task of searching? Okay, we don't want to hire 1,000 people who will keep a tap on, because the internet looks like it's growing heavily, right? This will not scale up. 800 will become 8 lakhs tomorrow and 8 million tomorrow. How can we hire so many people? There should be a way to automate this, all right? They thought and they realized that the best possible analogy to solve this problem is the following. There is some data on the internet that will probably tell us how to search and how to rank our searches. And they very successfully solved the problem. Yahoo failed miserably, unfortunately. All the people they hired to search obviously were asked to leave the job, or they changed their job and things like, I don't know what happened, I'm just guessing. But these 2 people solved the problem without hiring anybody. And they became a $1 trillion industry. You know, what's $1 million? What's $1 billion? What's $1 trillion? Trillion is 1 million is 1,000 times 1,000. Billion is 1,000 times million. Trillion is billion is 1,000 times million, and trillion is 1,000 times billion. Whatever it is, you search for what is $1 trillion, you will see. We now have $1 trillion industry called Google. Okay, what I'm going to tell you people today is a story of Google and how that used one of the most the sort of a costliest machine learning algorithm, all right, to solve a $1 trillion question, which is searching on the internet. What exactly did they do? I will give you the analogy and I'll give it on to Yayati to explain it to you people. There is the following. Analogously speaking, if you want to understand what does a person use, okay, so I want to come near your house and then sort of realize what products do you use. In your house, you will have a dad, a mom, a sister, and a couple of kids, and maybe an aunt or an uncle or an old person, etc. They all require some products. And you as a shopkeeper wants to understand what products do they use. You cannot go and ask them what products do you use. They'll say, buzz off. Why should I tell you, right? A best way to find out what products they use is to go and dig their dustbins. Okay, dustbin, their garbage bin. Look at their garbage bin. Give some money to the Kudawala. Kudawala is the person who collects the dustbin stuff. And tell me what diapers they use for their kid. Okay, tell me what kajal they use in their house. Okay, tell me what oil they use for their hair. I think if it's Parachute coconut oil, the Parachute box should be there in the garbage bin. All right, and that is probably a very nice marketing strategy today to understand what people use. Right. Also, this is how your Amazon also works, where they will observe that people who bought textbooks also buy notebooks. People who buy notebooks also buy pens. So if you buy textbooks, Amazon will immediately say recommended product. Okay, maybe a pen, paper, notebook. This is a very easy version of a more complicated algorithm. I'm just giving you a toned down version of what happens there. So recommender system is based on how people use stuff. After buying A, they buy B. Similarly, on Google also, they observed that looking at how people use, what people use, kind of an analogy, we can figure out how to rank the web. Now, what's the relationship? See, when Shakespeare says, all that glitters is not gold, he's not talking about gold. He's talking about the fact that people, by glitter, don't mistake that for good person. Okay, people may come with makeup, don't mistake that for beauty. He's trying to compare all that glitters is not gold with some metaphorical reality. All right. Similarly, what is more poetic in computer science is the fact that garbage data came in use, and that is very analogous to how Google works. Right. So now I have given you the example. Yayati will release the climax in making you people understand how Google works by making you play a small game. We are very interested to not, whether we are disinterested to take data set from somewhere on the internet and then crunch it and then show you. So our style will be slightly different. We will take data from you people, we'll generate data by making use of all the audience here. How many people are there? 64, that's a big number. In fact, if you didn't know, we can generate data at the order of the universe, atoms in the universe. With only 64 people. So Ayati will generate such data right now. She's going to make you people do an activity on the internet. So keep your desktops, laptops open if possible. If not, then you can even do it from your mobile, not a problem, but preferably do it from your desktop. You will enjoy the session like anything. Okay, on to Ayati. I repeat, how does Google work? Garbage idea. These two things, if you have understood, that's the take home message. And Ayati will collect data from you people and then show you how Google works. On to Ayati.
Thank you, sir.
Welcome. Ayati, are you there?
Thank you. Yes,
Yeah,
yes.
super. So you take care, Ayati. I will be in the mute mode. Huh?
Sure. Thank you so much, sir. Hi, everyone. I'm not sharing my video with you because I want my screen code and animations to be more interesting than me. So as sir said, what we are going to do is I'm not going to give you a talk to you. I'm not going to show you any PowerPoint presentation. What we are going to do is we'll play a small game and then all of us will see what we can together learn from the game. Not only you, but me also. We never know during this game, probably I'll get my next idea for my next paper and you can collaborate with me. We have around 72 people. So actually, what I would want you all to do is participate immensely. The more you participate, the better will be the talk. And I want you to leave a lot of comments in the chat box, throw in a lot of questions. Don't worry about your questions to be stupid. I have done stupid things all through my PhD. My advisor knows he's there. I want you to do the same. Be stupid, throw in a lot of questions, and we'll learn through them. So if all of you are with me, I would want all of you to raise your hand if you are with me. You can just maybe type a +1 in the chat window if you are with me in participating immensely in this activity. So that makes me know that you are in for the activity. Gaurav seems like the most active participant. Okay. Gaurav, Hani, Dr. Anjali. I'm waiting for more +1s. But that's the only way I can't see at your faces. That's the only way I know my participants are really with me. Okay, so what I'm going to do is I'm sharing a link here with you. I request all of you to open this link. What you have to do is start filling this data. So you can leave out on the key to fill your name, your hobbies, and the answer to why is computer science important in this sheet. So when we are doing this activity, you can help your peers, you can help your fellow mates understanding what we are doing if someone is confused. Meanwhile, you can also keep guessing what we are trying to do. So I really want to hear from you. What do you think I'm going to do with this data? What do you think can be done with this data? You can unmute yourself and speak, or you can type in the chat window. So keep filling the sheet and meanwhile keep guessing what we'll probably be doing with this data. So till now we have 15 participants on in the sheet. I would like to see more of you here. You just need to come to this sheet and flood it with the data. And I request you not to override the data of your fellow mates. You might want to spend some time thinking about why is computer science important. What I'll do is, meanwhile, I'll also share my screen with you so that you can actually keep seeing what is happening there on the sheet. So please note that we'll be able to continue with the activity only if we have the data corresponding to at least 30 participants, and I think that should be feasible given that we have around 70 participants. If there is any doubt or any query, please feel free to type it in the chat window. Can someone try to guess what are we doing? What can we do with this data? The organizers, you can also use this data to keep their attendance actually.
Yes, of course, ma'am. Thank you.
We'll have to spend some time thinking about how to answer this question, why is computer science important, and sooner you will realize why this question is important.
Ma'am, can I ask you a question, ma'am? Why some of the data is missing, ma'am? Somebody is not typing.
Yes, that is the reason. Actually, I've shared an empty sheet. So whatever you see here, except for the first row, is written by participants. So some of
Okay.
them probably left some rows empty and then started writing from the next row.
Yeah.
That's
Okay.
fine.
Okay, ma'am.
Girish, you can try to do it using your laptop. Otherwise, you might need the Google Sheet app. Or see if it is possible with the help of browser on your phone. Or better, what you can do is if some of you are facing problem in filling the sheet, maybe you can type in the chat window and I'll copy paste it on the sheet. So the values, whatever entries you want to fill in name, hobbies, and why is computer science important, you can go ahead and type it in the chat window and I'll do it for you. But everyone make sure that you participate. So still, I think we have around 25 entries. I'm giving you 5 minutes more to fill this sheet. If you have any doubts, make sure you ask them in the chat window or unmute yourself and ask it. Okay, what I'm doing is I'm deleting these empty rows in between just so that our data is continuous. It's just some form of cleaning the data. Okay, now the participants who have filled the sheet, I request you to fill in your key number. So your key is nothing but you start from 1, 2, 3, 4, so on and so forth. So Anjali ma'am gets a key number 1, Mega gets a key number 2, Joseph gets a key number 3. So please go on and fill your key numbers also. Make sure you fill the last column because it will be really important for the next part of the activity which is coming forward. What we are going to do is we are, as we were discussing about ranking the web pages in this talk, sooner or later we are going to rank you, and your ranking is going to be dependent on how smartly do you answer this question, why is computer science important? So you might want to search online, figure out some better answers and fill them in, and making sure you don't just copy paste. And you should make sure that your key is not same as the index which is mentioned on the left hand side. It will be 1 minus that index. Basically, it will be 1 minus a row number which you are filling in because we have a header there. Now you have 2 more minutes to fill this sheet, and then we'll start with the next part of this activity. Meanwhile, do someone want to guess what we are doing? Can you look at this data, just this data which we have filled till now, and try to guess what all can we do with this data? Assume that we have this data for all the Facebook users. So here we have done it for the participants of this workshop. Assume we have this data for all the users on Facebook. What all can you do with the help of such data? Assume you are the CEO of Facebook and you have all this data. What all can you do with it? We have 33 participants till now. But I should actually remove myself from this activity so that the results do not become skewed. Okay, so we'll move to the next part of the activity. All of you have now a key, as you can see in the first column. So what you should do is come to this second tab, which is endorsements here. So you see here, what you have to do is in the column A, fill your own key. So I'm typing your own key here. So this is for person having key 1, this column is for person having key 2, so on and so forth. So let me just rather extend this. So this is your key. What you have to do is fill in the data corresponding to your key. So as an example, let's say I'm talking about the person having key 8. So what that person should do is having key 8. Actually, let's see here, Swarna here. So what Swarna should do, she has a key 8. She should go through the hobbies and this column. Why is computer science important for all the participants here? And based on how participants have filled it, she should choose some 2 or 3 participants with whom she is impressed with. As an example, let's say I'm going through here and assume that I find this answer of Hani Fatima to be really smart. So I would like to endorse her that yes, she is a good participant and I would like to follow her. Or maybe I would want to do my next project with her. So what I'll do is I'll come to this endorsement section. Look at her key, it is 10. So I'll come to this endorsement section and fill a 10 in the, so assuming that let's say I'm having this key 2 here, so I'll type a 10 here. And then maybe I'm impressed with some other participant as well, say participant 34, I'll fill it here, so on and so forth. So you have to fill the keys of the people whom you are impressed with here. And it's not mandatory that you fill all the 7 keys here. So if you are impressed with only 2 people, fill in 2 entries. If you are impressed with 3 people, fill in 3 entries, so on and so forth. Right, so you can go ahead and flood this data. If you have any doubt in understanding what we are doing, let me know.
Ma'am, we can fill it up, no? There will not be any conflict of interest, right?
No, ma'am, you can start filling it. We can start filling it.
Okay, okay, ma'am. Okay, ma'am.
So as an example, you can see me how I am filling this data. So here is my key, it is 29. I fill in my hobbies and I fill in why is computer science important. Right. So done here. Next, I'll go through this sheet and I'll figure out certain people whom I will like and I'm going to fill it in the corresponding column in the endorsements. So make sure you fill the keys in your respective column. Not many people are filling it. I'll explain it once again. So what you have to do is all of your keys are there in the first column. You skim through all these sections here, hobbies and why is computer science important, and pick up some 4 to 5 people or 2 or 3 people which you like. Any number will do, 1, 2, 3, 4, 5. So pick out the people whom you like here. I think somebody has overwritten some data here. Can you just undo it somehow? Okay, some columns here have been hidden, it seems. Let me see if we can just get it right. Like some of the entries have been hidden here. Someone has by mistake done it. Okay, so for just a few minutes, maybe all of you can stop editing. What I'll do is I'll take this document to one of its previous versions so that we have all the entries here also. Or if someone knows how to just show these rows here, can you do it? So if you see here in this first sheet, we can't see the rows 7 to 16 here. Okay, thank you so much. Someone is editing it for us. Okay, maybe these columns, their size have been made very small or something like that. Thank you so much. Someone is very quickly correcting it. I think it has been corrected. Participants who were having keys 12 and 14, can you please come back and write your name here? See if something has been overwritten in your entries. Okay, you can start filling up this second sheet. So we don't have many entries as of now. Meanwhile, if any of you want to try to guess what we can do with this data, please let me know. Do you see what we are trying to do here? We are actually trying to generate a mini Twitter-like network. So in the first column here, when I asked you to fill in your names, hobbies, and why is computer science important, you are doing nothing. Rather, you are creating your profiles. So every row is a profile in itself. So Anjali ma'am has a profile where she has a name, her hobbies, and what she thinks about computer science, and same holds for everyone. So every participant has a profile here. Participant number 12, if you can please come back and type your name here. And participant number 14, if you can just fill in this last column, also holds for participant 12. Okay, so all of you have your profiles here. Right? So anyone of us can come here and look at the profiles, and this second sheet over here actually tells us who follows whom. So this participant number 1 here tells if she is given a chance to look through the profiles of all the people, which are the people who are the people which she will follow. Same hold for participant number 3, who will actually follow, as of now, only one person. Participant 8 will follow 5 people, and you can actually see those people here, right? So what we are doing essentially here is generating a mini Twitter network, and we are going to analyze this mini Twitter network. What all will it give us analyzing this mini Twitter network? So one thing which is going to be surprising is when you will look at these features of this mini Twitter network, which we generated from your data, those features will exactly be the same as what happens in the real Twitter data. So this is one thing which is very interesting. If you look at these social networks, which are made of these relationships between people, every person is a node, and if there is a connection between two people, you have an edge between those people. You can make such a network, you can make such a graph for any social network, be it Facebook, Twitter, LinkedIn, or anything. So when you look at the connections in these networks, there are certain reasons how these connections are formed, and they depend on the sociology and psychology of individuals, which has not changed from the time even when our ancestors were there. So even if you look at this network here, I'm soon going to show you this network here, how it looks like. But I request all of you to actually go and fill in this data. Otherwise, we'll have very less number of edges in this network. So for very, what I would say, aesthetic network, which looks visually appealing to all of us, I would need all of you to fill in this data regarding the participants whom you would like to follow. And then I would show you this network, and then we'll look at the features of this network, which are same in the real Twitter network as well. Rather, if you will look at this network between our ancestors, assume that I could go back in time and create this same network between our ancestors, the properties of the network will remain the same. They have not changed with time. They have not changed depending on whether we are online and offline. And what are those properties? We'll discuss it soon, once we have sufficient number of entries in this second sheet here. Okay, so all the people who have finished editing the sheet, can you just type a +1 in the chat window? Angela and Shiva Priya, maybe I can have your information here. It's not here, just search. Okay, we have 2 more entries. I'm sorry, I'll just update it in this sheet. Meanwhile, all of you can keep filling in the sheet. So I'm updating 2 more entries in this sheet. Okay, so we have 2 more entries here. Maybe all of you I want to take a look at these. We have 41 people in this network as of now. Okay. So all the people who are finished with the activity, finished with filling this data, please type a +1 in the chat window. Those who are facing a problem in editing, please type a -1. What I'm going to do now is I'm going to convert this data here, the one which all of you have filled in the endorsements here, into a network. If you are you still have 2 to 3 minutes to edit this sheet, please go ahead and fill in the entries if you haven't yet done so. So what I'll do is I'm going to convert this entire data in a graph, which is nothing but a Twitter-like graph. So what will be the graph? Every person here, every key here will be a node, and you will be having an edge from one person to the other if that person follows. So you'll have an edge from node 1 to node 2, node 1 to node 4, node 5 to node 30, node 8 to node 22, so on and so forth. You'll have the edges in that network. So I hope all of you understand what the graph will be. So while I'm crunching this data, I have a small fun quiz for you. So think about how this graph will look like, and based on what you think, please go ahead and answer this small Google form. You can just go to this form and uh, try to answer some questions there. If anyone has any questions, you can unmute and speak.
Yeah, ma'am, I have a question. In the Google form, it's a question given, will the graph be connected? And
Okay,
yeah, the option one is only given there. It is not given yes or no. So what should we
okay.
do?
So for that, you can assume that I think you can leave that question. It's not required. So if you fill option one, it means you are saying a yes, and if you leave out that question, it means a no.
Okay, okay, ma'am. Thank you.
So that also tells me how many of you are filling the form.
Ma'am, could you please explain it once more about which graph we are speaking?
Okay, so the graph which we are generating, so if you just a second, I'll share my screen with you. So if you look at this graph here, so what we are going to do, we are going to convert this data in a graph, a Twitter-like graph. So here all of you have told which other people do you follow. So node 1 here follows these 7 people, node 2 follows here these 5 people, so on and so forth. So the graph will be essentially a Twitter-like graph where you will be having an edge between, you'll have an edge from A to B if A follows B. So with mainly you will be having an edge from 1 to 2, you will have an edge from 5 to 30, 5 to 4, similarly from 10 to 18, and then 10 to 10 also, that's interesting, and from node 16 to 1. So you'll put all those edges and you'll be having a graph, and the questions are regarding that graph. I hope it's clear.
Yes, ma'am.
Okay, so I have got the responses. Okay, maybe we can look at certain answers and then we'll start with the analysis of this graph here. Okay, so will the graph be directed? So most of the people say yes, almost more than 50%. Will the graph be connected? Almost everyone unanimously says yes, it will be connected. And actually, you should be asking questions like, will the graph be strongly connected? I hope you have studied basic graph theory. Will there be isolated nodes in the graph? Yes. Will there be pendant vertices? That is, vertices hanging out from the graph? Yes. And these are certain questions you would want to ask from this graph. How is this helpful? What is shortest path? Okay, where is the graph? You'll see it soon. Okay, so I'll show you this graph. We are not left with much of a time. So please note that this is a graph I have generated from the data I have collected from all of you. I'm just going to show you now how this graph will look like. So this is a graph which we have generated from our participants. Yes. So this is how the graph looks like. So these are the isolated nodes probably who have filled in sheet 1 but have somehow not been able to fill the endorsement sheets, and that's perfectly fine. But what you can see here is, if you ignore the arrows for now, definitely this graph is disconnected. We have components, but still we have this one big network here, right? One big component here. So meanwhile, if you ignore these edges, so actually this entire graph is connected. This also happens in your graph like Facebook and Twitter. If you look at these endorsement sheets, we do not really have a lot of ties here. Rather, you will see that for many rows, we have actually 0 entries, right? Who have said that they really want endorse anyone else. But even with that much less number of edges, the graph is actually connected. And it actually comes out that if you have a graph with n nodes, if you sprinkle these edges randomly, if you put in log n number of edges, your graph will be connected. Okay. Now, I would want to ask you, what other questions would you want to answer from this graph? So this is a graph between the participants. All of you are the participants. So here you can see here node 17 endorses node 41, node 23 endorses node 20, node 1 endorses node 4, endorses node 5, so on and so forth. And here is the graph in front of you. So what questions would you want to ask from this graph? So I'll quickly go through and tell you a few questions we can answer from this graph. I'll be really quick here. Do not worry about the code here. We can always send you the code later on. So few questions I would want to ask from this graph is, how many nodes are there? How many edges are there? Right? So you can actually see it here. We have 40 nodes and 77 edges in this graph. Edge density is, out of the possible number of edges, how many do we actually have? Actually, we have only 5% of the possible edges in this graph, which means if 100 edges were possible, we have only 5, and yet this graph is connected. Okay. Another thing I would want to see here is what is the reciprocity in this graph? Basically, do I have a phenomenon or a behavior like, if node 1 says node 2 is my friend, node 2 also says node 1 is my friend? So most of the times what will happen if the participants, they know each other beforehand. So while filling out this sheet, you can see a I scratch your back, you scratch my back kind of a phenomenon here. Is that happening here? And for that, we can actually look at how many of these edges are reciprocating each other, right? So I'm going to do that here. So the reciprocity in this graph is only 15%. In one of the FDPs which we had, the reciprocity was actually 60%. So reciprocity being 15% actually tells you that the data is genuine. And most of the people, they have actually looked at the hobbies and how they have answered that question there to decide whom they follow. Okay. Next, I'm going to convert this graph in an undirected one. So here we have kind of a followship network. Whom do you follow? But assume that I do not want to look at whom do people follow. Rather, I'm more interested in assume that all of you are working on some research projects after this session we are having today. So in that research project, who would you want to be a partner with? So definitely if you follow someone means you want to be a partner with him, but actually you can be a partner with him only if that person follows you back. So what I'm going to do is I'm going to collapse all the unidirectional edges from this graph and only keep the edges which are bidirectional, where both of the people follow each other. Furthermore, a person cannot be a partner with himself. So many a times a person endorses himself or herself. We are going to remove those kind of types here. And then let us look at what do this graph look like. If you see here, as soon as we change this graph in an undirected graph, this is what you get. Rather, most of the edges collapse, most of the edges were unidirectional, and it turns out that actually there will be only two project groups in this entire session, one having these people here and other having these three people over here. Okay. Another question. Let me come back to this graph here. This one here, in which we had these directed edges. Assume that I want to get this information. If I really had to choose one participant who can tell me, assume that I missed this session and I want to have one participant who can very well tell me about what happened in the session, who that participant will be. Indirectly, I'm asking who is the most important participant in this network if I want to rank the participants. So this question is similar to the Google PageRank question, which we were discussing before. Assume that, so how Google answers this question is, uh, assume that the participants here, they are nothing but they are the web pages. So 26 is a web page here, 12 is a web page here. And what are these edges telling you? The edges are telling you which web page is referring to which other web page. So whenever I go on Google, I have a web page. Let's say a Wikipedia article, which is here. So this is the Wikipedia article. This Wikipedia article might be having the link to another Wikipedia article, which can be this one. So I have an edge running from this article to this article, right? And I want to figure out which is the most important article. So the very first measure which will come in our mind is look at which article is being referred by most of the people. In this case, it is article number 1. So most of the people are referring to this particular article, probably it should be important. But this method might fail. Why? Because if I know this is how Google works, I'll actually create 20,000 spurious web pages and I'll make all those web pages refer to my own web page, which will increase its degree, thereby increasing its importance. So Google doesn't do it that way. What Google does is, I'm not going to go into the mathematics of it. I'm just, I'll give you a naive idea. Google will start running on this graph here. So you know about crawlers, the web crawlers. So there will be a crawler. It will start from this page 1 here, go to a random page from this node 1, let's say, which is node 5, and then go to node 22. And it will keep on moving in this network here and there. And at the end, it will count which page is visited the most. And it will report that page to be the most important. So I'm actually going to run that algorithm on this graph, and so we'll run that algorithm on this graph and see here which participants will be the most visited if you start taking a random walk on this graph. So let me just do that. and it figures, it turns out that these are the participants actually. 28, 12, 7 and 2. So let's just look here. Where do we have 20? So this participant over here. So it turns out that this participant actually doesn't have a very high in degree. Not a lot of participants refer to this particular participant here, but this participant, most of the important participants actually refer to this participant over here. So we have a few more here, right? So this is how actually Google works. So this is what the result will look like if you run a Google page ranking on this graph over here. Yes. So our motivation in this session was not to flood you with a whole lot of information, rather to tell you how you can use the data which you can randomly collect, which you can easily collect from the people in an exciting way. So there are few more things which you can do with this graph. We do not have much of a time, but maybe I can quickly tell you. So sometimes it is not important, again, which participant is visited the most. What becomes important is which participant is responsible for connecting the two components. So if you look at this graph here, so we do not have an edge. Assume that 1 was connected to 9. So the node 1 will actually become important in the sense that it is connecting two groups. Sometimes you would want to look at the which participants are closely bound in the network. That is, there can be two nodes which are having a degree 2. So as an example, look at this node 10 here. It is friends with node 18 and node 9. Node 4 is also having a degree 2 connected with 1 and 5 here. But in the case of node 10, 18 and 9 are not friends with each other, right? His friends do not know each other. But for the node 4, 1 and 5 know each other. So 4 is closely bound in the network. We call it clustering. And a sociological result shows that teenage girls who have this lesser value of clustering, basically whose friends are not well connected with each other, are more prone to committing suicide. So we can study these network and answer questions like this. We can also, so this network here in this particular case is very sparse. If we were having more links running around, we could actually predict which participants are more likely to become friends. So in this particular case, if you look at here, we can easily tell 18 and 9 are more likely to become friends because 10 is a friend with both of them. Similarly, 5 and 2 are likely to become friends, 4 and 2 are likely to become friends, so on and so forth. So for that, you can actually look at the number of common friends you have. The mutual number of friends is one basic criteria which you can use, but definitely there are more advanced algorithms to do that. So I think I will stop here. If you have certain questions in your mind which you can think one can answer from this graph, do let me in the chat window. If you have any doubts, please type them in the chat window.
I request all the participants to please share your doubts if you have any. I think they are not asking any questions because it was clear, ma'am.
Okay.
So thank you, ma'am, for giving such a wonderful session. Thank you, Sudarshan sir, and thank you, Yayadi ma'am.
Thank you so much, ma'am.
Yeah, I hope the students also have experienced a very good introduction about how graph theory can be used in analyzing social networks. So I do have a fundamental question, ma'am. Can the same technique be used to analyze other networks, like we have some industrial applications of graph theory also, right? So
Yes.
can the same techniques be used to analyze those type of networks, ma'am?
Yes, actually, I should have highlighted that. Thanks for bringing it in light. Yes, very much. So, here we have discussed about one particular social network. In general, we call these networks as complex networks, and you can make them on in any kind of situation where you think that a network can be useful. It can be between companies, it can be between brain cells. And actually, if you search it out on Google Scholar, you will find a lot of papers who are studying protein-protein interaction networks with the help of graph theory like this. Now you can study collaboration networks, co-authorship networks, a lot of other networks, and web graph is definitely one such network which we have discussed.
Thank you, ma'am. Our coordinator of STAR scheme, Dr. Sister Sylvie Matthew, has also joined. Sister, could you please give us small felicitations, sister? Sister, your mic is, please unmute your mic, sister.
Okay, Miss, all the best wishes for your program. Okay, thank you for conducting such a wonderful sessions, especially coordinator Anjali ma'am and all the faculty members of mathematics and your alumni faculty. I congratulate all of you for conducting such a wonderful webinar. Thank you.
Thank you, sister. Thank you.
Thank you, sister. Thank you very much.
Thank you, ma'am. Thank you, sir. Nice.
Now I would like to invite Alfie of Little Flower College, Guruvayur, to give away the vote of thanks.
Good morning, everyone. Data crunching, dusting data to our rescue. I think this caption itself, the title itself is very new and interesting to all of us. I have no words to explain how different was this session for all of us. Thank you, Dr. Sudarshan Iyengar and Dr. Yayadi Gupta for such a wonderful interactive session. It was a new experience to me and I think for all of us to actually see live what is happening with our data and how the internet is analyzing each and every click that we make in our computers to analyze each and every person of in us. So thank you for that wonderful experience. So thank you for the guide student duo for this informative session. I can see a spark between them. They are so connected to each other. That is, they are very much connected. I very much like that duo for this session. Thank you. And also, I take this opportunity to thank the Department of Mathematics of Vimala College, especially the coordinator, Dr. Anjali Kishore, and all the team of Ms. Swarna, Goli, Miss everyone for this conducting this wonderful webinar series. And we all are eagerly waiting for the next sessions of this webinar series. Thank you on behalf of me and all the participants. Thank you.
Thank you, Alfie. Thank you.
So once again, I would like to thank our resource persons, Dr. Sudarshan sir and Dr. Yayadi ma'am, and also to all the participants who have come here today for the webinar. The feedback link is given in the chat box. Please do give the feedback. And I hope we can wind up, right, Swarna ma'am? Swarna miss? I think she has got some network issue. Okay, so thank you once again. Thank you all.